If you're watching this, you probably use AI every day without thinking about it. A draft you let it fix, a search you don't question, or a recommendation you follow without asking why. In a world where so much now runs through these systems, having an edge doesn't come from one more prompt trick, but from understanding the invisible architecture that decides who wins and who loses in this new era. To see that clearly, we have to look backwards, back to the people, the ideas, and the hardware that turned artificial intelligence from an abstract question into the machinery underneath the economy. Because the story has a habit of repeating itself. And if you don't recognize the pattern, you end up playing by someone else's rules.
By the way, I will be whispering some hints every then and now, so pay close attention to the questions that slip in between the chapters.
This is the story of the AI. A solitary lamp, a table saturated with papers, and a man who listens to the ticking of the clock as if measuring the patience of the universe. Alan Turing writes, "Computing machinery and intelligence" in 1950, but what he actually traces on that paper is a metaphysical crack. The idea that thought can be imitated, that a machine, if it behaves like us, must be treated as one of us. Turing calls it the imitation game. The experiment is simple. If you cannot distinguish the machine from the human, the frontier has broken. There is no blood, no scorched wires, no explosions. Only text, questions and answers. A conversation like any other. There begins the metamorphosis of silicon, in a dialogue where it no longer matters who is speaking. In parallel, Isaac Asimov plays another type of magic. His 3 laws of robotics are not safety protocols, but incantations. Mantras written so that humanity sleeps soundly while imagining obedient, docile robots, incapable of harming their creator. But every spell reveals its hidden fear. The dread that, if there are no laws, the creature will turn against the master.
Back then, they believed every aspect of learning could be described and simulated. Does that sound so different from today's pitch decks?
Frank Rosenblatt presents the perceptron in 1958, a crude device, almost artisanal, which is nevertheless the direct ancestor of the neural monsters we train today at millions of dollars an hour. The perceptron is a promise, the idea that a network of simple connected nodes can learn. What no one understands yet is that this network will not only learn patterns, it will learn to model the world. Meanwhile, in a gray and silent terminal, Eliza is born. Joseph Weizenbaum programs a rudimentary psychotherapist in 1966 and discovers something disturbing: humans confessing traumas to a trivial sequence of rules. The Eliza effect does not speak of the machine, but of us. We want to believe. We are willing to project emotions onto anything that returns our own words with a minimally convincing echo. But the 70s bring the winter. The fantasy crashes against the friction of hardware. Without data, without power, without GPS, the dreams of Dartmouth freeze. Governments cut funding, companies close laboratories, and the discipline enters the first dark age, the AI winter.
A field oversold, investors impatient, promises that hardware couldn't keep. They called it an AI winter. Does any of that feel uncomfortably familiar?
Geoffrey Hinton, the so-called godfather of AI, insists where others have given up. In the 80s, he popularizes the backpropagation algorithm, a procedure that allows machines to correct themselves, adjust weights, fine-tune connections. It doesn't seem like a revolution, but it is the missing piece so that a neural network can finally learn from error as an injured organism does. Before reaching 2000s, Deep Blue, IBM's machine, defeats Garry Kasparov at chess. That symbol of strategic human intelligence falls before a computational brute force. The message is clear. It is not necessary to think like a human to win. It is enough to explore more possibilities, faster with more coldness. The world interprets it as a laboratory trick. It does not yet see that it is a dress rehearsal for what is to come. Systems that surpass human intuition in closed domains first. And then, in open spaces.
Every era has its heretics. The only question is whether you hear them before or after they win.
Fei-Fei Li looks at the problem from another direction. We don't just need better algorithms, we need a world that the machine can see. In 2009, she builds ImageNet, a massive database of labeled images. Millions of photographs classified, turned into visual food. It is the first all-you-can-eat buffet in history for an AI hungry for patterns. In 2012, AlexNet appears as the collision between software and hardware. For the first time, NVIDIA lends its GPUs, designed for video games and 3D graphics, to train a deep vision model with overwhelming success. The result is devastating. Precision skyrockets, errors fall. That year, NVIDIA stops being just a graphics card company. Its ascent toward global hegemony of calculation begins.
When you hear, "We just need more data," do you ever stop to ask whose data they mean?
In November 2022, a simple browser tab with a text box where someone typed "hello" became, in less than 3 years, the fastest adopted technology in history. People realized they could talk to a statistical engine trained on trillions of words, an always-on voice that explains, translates, codes, drafts, and imitates on demand. For most, it's just another app, yet every prompt and every reply disappears into a growing silent layer beneath everyday life. By 2026, that layer has become the nervous system of civilization. In entire regions, more than half the population uses generative AI for almost everything. Companies have moved from pilots to structural dependence. Over 90% weave models into hiring, pricing, logistics, and reporting. In hospitals, dashboards powered by AI quietly decide how critical resources are allocated. No one sees the system, but its matrices quietly hold the balance. So far, we've gone from thought experiments on paper to machines that quietly sit between almost every decision we make. From a handful of equations and sand to a nervous system that wraps around the planet. But it still leaves 3 uncomfortable questions open. What is this intelligence really doing under the hood? What does it need in order to exist? And who controls each part of it? I'd invite you to sit with those questions for a moment before we start opening the box and looking at how this thing is really built, piece by piece.